Right, so this is, I guess, working. And yeah, so everything is working. Okay, it looks stable now, finally. I'm super happy about it. It was really a rough start. Okay, I think the chat is working also. Okay, so what I would like to cover in this video, I would like to create a very simple game in a phaser framework. I recently get into the gaming, not into the gaming, but into the creating of the games. And I wanted to start with the JavaScript, and the phaser framework looked like the best starter for me. And here is the application we will be actually working on, a very simple Flappy Bird application. As you can see here, okay, we'll be creating clone of this. Here is also code of this guy that he wrote. I will be slightly refactoring it. I will be writing it much simpler, and we will go step by step how to create this. But you can give some credits to this guy. All right, I'll just verifying if everything it's fine here. Yeah. Okay. Everything looks good. I hope camera and everything is working. I'm just now checking my internet always if it's working. But yeah, now looks stable. Okay. Okay, guys. If you're ready, we can start working on some programming. Alright, so first of all, you need to have a Node.js environment, of course. So just to be sure, you can open your terminals, and if you want to code, of course, if you just want to watch how I will be coding, you will just watching. No big deal in this. Okay, so Node-V to verify your Node version. If you don't have a Node version, go ahead and install it. You can stop the video. You can continue it after you are ready. Alright. And yeah, simply Node.js, and you will install Node.js environment. All right, so if you have a Node.js, we can initialize project, and you will initialize your project from my Github repository. Okay, so here is a Github repository. You can find the link. I will show it to you in a second. Okay, phaser webpack boilerplate. So here is a boilerplate code. And yeah, here is the address. So yarga99/phaser-webpack-boilerplate. All right, and I will be cloning this, and this is basic boilerplate for a game. As I mentioned before, we will be working in a phaser 3 framework, which is a gaming framework. It provides all the functionalities and API and functions that you can use in order to create games. Okay, and if you will learn really phaser framework or any other gaming framework, you don't have any problems to catch up in some other engines like for example Unity or Unreal Engine. So it's always good to start simple and then get into more difficult topics. All right, but I don't want to waste your time, so I will start coding. Okay, so I will go here to my GitHub repository. Is here on this link. I will include this link here. All right, and you can clone the GitHub repository. You can just download zip. So I will download the zip file. All right, and let's open this. Okay, so phaser webpack boilerplate -main will go into this folder. So if you are in the terminals, you can go into this folder. So to the home folder, I'm already in the home. I don't know why I'm writing it. So let's go to downloads. I will stay in the downloads. You can move your file into any folder you want, really. All right, and then I will go to the phaser. Actually, how it's called, phaser webpack boilerplate. Okay, so phaser.webpack-boilerplate. All right, -main. All right, and here we need to run npm install. Okay, I will check. I don't know really how often I'm going to cover this. I'm just testing it at the first time. I want to work on something very simple. First time, just want to create a simple game, Flappy Bird clone. So that will be basically the content for this session. And in the future, I really don't know yet. I don't know how many viewers it will be watching. It's yeah, it's kind of hard to build a community, but I can do it even for 5 people, for 2 people, for for one person. We'll see how it will be going today, and then we'll see. So we'll be working on this Flappy Bird clone, Flappy Bird clone game. We'll be creating just a small part of this game, and in a future session, let's say next week, I will be covering the rest, and also all this content will be included in my new course. We'll be creating much more complicated game. I can show it to you right now, but after that we'll start really programming. So let me show the game I already prepared in the course, not this course, but on my platform there is already course on Eindcode Academy, and we'll be creating this platformer game you will see in a second. Alright, so I can already close this. I will go to my here and I will go to localhost 8080. I'll be working on such a simple platformer game, but you will learn all of the basics and basic concepts and practices how to create the games. Okay, I was testing a little bit, so I moved some objects around. Alright, so level 1, and yeah, so simple platformer game. You will have a traps, you can collect the coins, you can shoot the projectiles. Currently you can see the debug mode, so these parts here, this pink part, that's the colliders around the body of the player. There are other game objects you can collect. I will be talking about the raycasting in this game, and so on. Okay, but this is the content for the course. In this video, in this session, I will be covering the Flappy Bird, which will be very simple game. Alright guys, okay, so I will not talk about this game here, but we'll create a Flappy Bird clone. So yeah, let's start now. All the dependencies should be installed. So go to your project folder, and if all of the dependencies from my Github repository, you can just simply run here npm run dev, and this will start the local host on 8080, and you can visit your game. Alright, so this will start a server. If you didn't watch before how to set up this project, you can just go backwards in the video, and then you will find the part where I'm initializing this project from my Github repository. You can just download it and run it. Alright, so I will go to localhost 8080, and you can see here is our initial game. So now it's time to open our coding editors and take a look at why this is displayed here. Okay, so we'll get into the basics of Phaser framework. I will open here our Phaser game. So let's open here in a downloads folder. We should have our game, Phaser Webpack boilerplate-main. Alright, and that's how it looks like. The initialized code of the Phaser is an index.js file where it's basically bootstrapping your application. It's initializing your game instance here. So we are importing here Phaser, basically Phaser framework that contains the game function which you are calling which it's containing game constructor, and this will create an instance of the game with the config you are providing up here. And we can talk separately about all of these options here. So when you are creating the Phaser game, everything is initialized in the canvas. So first you need to define the size of the canvas. Okay, to make it simpler, I will remove everything, so we'll start from the scratch with the empty file, and now when I will go to the browser, you will see nothing is here. So we need to create a canvas, we need to create an instance of the game, we need to provide some initial config. Alright, so let's do it. Let's create here, let's first import here Phaser from Phaser. So import Phaser from Phaser. That's how you're starting. And then you will create a configuration object which will define how your game will look like. To the configuration object, you will provide the width and the height of the canvas. So width, let's say 800 pixels. This is the size in the pixels, and the height will be 600 pixels. Also, you will provide here type of the renderer. We will provide automatically the type renderer. So, okay, nothing in the chat. So we will provide here a type of the renderer, and usually you will resolve it automatically with a phaser.auto. This will find the renderer automatically, and default renderer is called Webgl. Okay, so web graphics library, it's included almost in every new browser WebGL library. Okay, so if you don't know what's a WebGL, of course, I'm always encouraging just to search on internet, so WebGL. Okay, so it's a library for rendering graphics. And if you see here this cube, it means your browser supports WebGL. Okay, so of course, Phaser framework is built on top of the WebGL, so it has to be if we want to render graphics. Okay, so Phaser.auto will look up for a renderer. By default, WebGL is the renderer. Okay, so we have a width, we have a height, and then we'll define the physics. Okay, and in a physics, you will provide a default physics library. It's called arcade library. Okay, so you'll provide here arcade. You have different types of libraries you can provide into your game. So by physics, I mean how the gravity will be, for example, applied to your game objects. For example, when you will create some cube and it will be falling down, how the gravity force will be applied to the cube as it is falling down. All right, this is the lightweight library. Arcade, you have also other types of libraries. For example, you have a matter.js. All right, this is the other type of the library you can use, but you need to install it. Arcade we don't need to install, so you can see this is basically physics engine for the web, as it's saying here. Okay, but we are using arcade. Okay, so we'll close this. We'll continue in our configuration. So by default, we'll use the physics of the arcade, and I guess we are done with the physics, and we'll create a new instance of our game. So we'll create here a new phaser.game, and we'll provide here config. All right. Okay, we'll take a look here and we'll see here only the black screen. That's actually correct, because when we want to display here something in our canvas, we need to create some game object. We need to maybe load some images and display the images here. All right, but we are not doing it yet. We are just creating empty configuration and we are providing this configuration into the game. So we have here type for the renderer, width, height for the size of the canvas, physics for the physics library, which we are using, arcade. All right, so okay, no questions here. And the second thing what we need to do here is to load here some scenes. Okay, I'll be talking in the scenes in a second. So let me see if this stream is working good. I need to check it. I'm now paranoid because it wasn't working at all at the start. So let me see. Yeah, I think it looks stable now. All right, so now let's get into the scenes. In the Phaser framework, you can have in Phaser game, you can have multiple scenes, and every scene displays different stage of your game. All right, so for example, this is our current active scene. We didn't define any active scene, but this is let's say this is our active scene. Here, later we'll create a game object, and these game objects will be interact with each other together. Okay, we'll have some game objects, maybe some cubes, and the cubes can move on the screen. We can have some player, and the player will be moving and jumping and so on. So that's the active scene. Okay, current active instance of the game. Of course, you can have multiple scenes. For example, every game has a for sure menu. Okay, so you can have a menu scene, right? So you have a menu scene where you have for example, options like a play game. All right, maybe you have options. It's very hard to type on the touchpad. Options. All right, and the exit. You can exit the game. Okay, so by default, when we will go to our game, our menu scene will be displayed. From menu scene, we can go to the play scene, and the play scene will initialize our game where we'll have this player which can move in some environment. From the play scene, we can go back, let's say, to the menu scene, and in the menu scene we can go to the options, and from the options we can go to option scene, which will be different types of the options. Okay, some another menu where we can toggle some options in our game. Okay, so you can have multiple scenes in your game. That's the point. All right. Okay, so we need to create these scenes. We will do it like this. Let's go back here to our coding editors, and in the src folder, I will create a new folder. I will call it simply scenes. In the scene, we'll create a new file and we'll call it, let's say, play scene, or just simply play. And in a play scene, I will import, you will do it almost always, you will import a phaser from phaser, and then you will create a new class. And we can call it as we want, of course. I will call it play scene, or just a play scene is a good name. And play scene needs to extend some base class. When you want to create a phaser scene, you need to extend here. And you will extend base class phaser.scene. All right. And then you will export default the scene, export default play scene. All right. And then when you are extending from a superclass, you need to call here constructor and super in a constructor. So super is basically calling the constructor in the superclass of the phaser scene. And to the super scene, you need to provide some data. You need to provide a name of your scene. This will be identifier of your scene, okay? So identifier of the scene. And you will pass here some unique string, the name of the scene, and I will call it simply play scene. And that's it. All right, then we'll get this play scene into our scenes index.js, into our game configuration. So I will import here play scene from a scenes, the same folder, right? So the scenes, okay, scenes and the play, and we'll get this play scene here. So under the physics, I will write here, it should be called scenes. All right, and the scenes will provide the array, and it will provide here scenes. If you have more scenes, you will provide here more scenes, but so far we have only one scene here, so there is nothing else we can do here. All right, so the scenes are loaded here. So far, I will not see any change here because we are not displaying anything. We have only empty scene. We are not defining here any game objects. We are not creating here any interactions. All right, so I will just check it if everything is working. And you can always check also your console. So you will open your development tools. And if you don't see here any issues, everything is fine. I think I will move it to the right side. All right, so we have our canvas. We have 800 times 600 pixels here on the canvas. I need to emphasize here that our canvas has a 600. Wait a second here. I cannot draw the straight line with the touchpad. All right, so this is the starting point. Or actually, I should say the starting point is here. I will write it like this. I don't know why I'm struggling, but I can draw here arrow very simply. All right. Okay, so here is the width of the canvas and the height of the canvas, right? So basically we can say this is the x-axis and this is y-axis here. On the x-axis we defined 800 pixels, so this point in the end is the 800 point. All right, and here on the y we have a 6. Remember, we have defined size of the canvas 8 times 16, 860 times 600, so 800 times 600. Okay, I already see that we'll struggle to write with the touchpad. And therefore, here is the start of the coordinate system. And the start of the canvas is a point 0, 0. This will be necessary to know later, okay? So there is a point 0, 0. Okay, this is the size of the canvas. X-axis, Y-axis, 800 pixels in the width and 600 pixels in the height. All right, so yeah, the canvas looks like this. We'll disable this and we'll continue and we will start loading some image. We will load here a background of our game. All right, so just let me verify here. I'll be switching between my two computers because on other computer I have my chat window and I'm checking if the streaming is going good. Here, then the stream looks good, and here, okay. All right, so we want to display here now image. So let's display here image. In your project folder, you have an assets folder. In the assets folder, you have a couple of images. For example, back.png, bird.png, which is just a yellow square, bird sprite, bomb, dew.png, pause button, pipe.png, platform, sky.png, and star.png. What we want to load here is a sky.png image. The size of this image is exactly 800 times 600 pixels, 800 in the width, 600 in the height. You can notice that the width and the height of this image is exactly the same as the size of our canvas. Our canvas has a 800 times 600 pixels. So if you want to load this image, you need to specify here lifecycle functions. Every scene has a lifecycle functions. Every phaser scene has a lifecycle function called preload and create. Preload lifecycle function is used for preloading or loading assets as the static files, as the PNG files, so images, music, sound effects, or animations. In a preload, we want to load this sky image, all right? Okay, so here in preload, we load sky image. I will write here a comment, so load static files or preload static files, preload static files, and here we'll create instances of the game object. Okay, so create function is called exactly once when your scene is initialized. So it's called once. You will initialize game objects, interactions. You will subscribe to events, subscribe to events. So all of the initialization of your game you will do in a create function. In a preload you are preloading files. In a create you are creating the actual game objects. All right, so you want to preload here image. When you want to preload the image, you will write here this. On this context, this is the context of your scene, and on this context you have a set of properties, sets of the functions and objects you can access. If you would like to know about all of these objects, you need to always go to API documentation of the phaser framework. So you can simply, just a little bit off topic, you will always start with the phaser tree and you will search what you're looking for example, scene. You will find the API documentation, and here is everything about the scene. So for example, we want to load here. So here is a function load in the right side, you can see, and a scene level loader plugin. Okay, so this is used for loading assets. All right, so here is a loader plugin, and we need to use it when we want to load the assets. So they have very nice documentation with the descriptions, and also you can find a lot of examples on the phaser. All right, so let's load this image. So I will go to coding editor, and in the preload we'll load here. So this load.image, and we'll load the image. To the image function, you need to provide a key of the image. So we can call this image sky because it is a sky image, and the second value is the path to your file in the assets folder. So we'll load it. So we'll provide the assets folder and then sky.png. So that's the location of our image in the assets folder /sky.png. So this image here. In the create function, we would like to display this image. So you'll write here this add.image, and this will add the image. To the image, you need to provide here x coordinate, y coordinate, and a texture. So let's say x coordinate will be, let's say 0, 0. And the texture will be the image we have preloaded here. So this is a sky image. Let's save this now, and let's go back to our browsers. And you will see, actually I will not see anything here because we have not loaded anything. All right, so let's see what's actually wrong here. This creates new image object. X coordinate we have provided also y coordinate, but the sky image is not loaded. Okay, I'll just check here. We don't have here any issues in the console. Okay, I'll try to provide here different coordinates. So 400, 300. All right. Okay, the image is not loaded for some reason. Okay, let me see where is the problem. Okay, I'm preloading the image correctly. Create BG, this add image. Yeah, I don't see here any issues in this. It's very interesting actually. Create function is here, placing is correctly initialized here. So let me, okay. Let me write here debug errors. All right, so we are not calling even our lifecycle functions are not executed. So there is definitely some issue with our placing. All right, so do I'm running the correct file here? It happened to me multiple times that I was editing the wrong file, but in this case I think I'm in a correct file here. Okay. We have here another very interesting issue that always happens when you are doing something live, and I need to find the issue. All right, so that will be very interesting to find the issue now. Okay, index.js, we have here scenes. I think maybe in the index.js could be issue. I already see issue, guys. Okay. So problem why not everything is loaded is because here shouldn't be scenes, but it's called scene, which is a little bit confusing since you can provide here multiple scenes. All right, so yeah, this is called scene. My mistake, guys. I'm sorry for delay here, but we can remove the debug errors here. All right, and now everything should work. Okay, so I'll save this. I will go back to browser. And now I'm going to debugger and everything should be working. So now we are displaying the image exactly in the center of the canvas. And I would like to explain you why the image is displayed in the canvas, in the center of the canvas. So first let's provide here coordinate 0, 0. When you will provide the coordinate 0, 0, your image will be added in the halfway. All right, why it's happening this? I will show you again coordinate system, so maybe it will make more sense. All right, so I'll get rid of some things here. So for example, I'll get rid of this. Okay, so as I mentioned, this coordinate here is coordinate 0, 0. Okay, 0, here is a 0. We are loading our sky image, so imagine our sky image is this image here. All right, and every image, every game asset we are loading have an origin point, how it will be inserted into the canvas. By the default, origin point of the sky.png is the center of the image. So you can imagine as the center of the image is inserted into the point 0, 0. All right, so that's why you can see only this right bottom part here, this part here. All right, so you can imagine the rest of the image is hidden out of the canvas. Yes, you can imagine the rest of the image is here. So that's why when you are providing 0, 0 point of the image, it's inserted like this. I'll revert this because you will be still using this image very soon. All right. But when you will provide the center of your canvas, and center of our canvas is 400, so I shouldn't get rid of my tools here. So center of the canvas is on the x-axis we have a 400 point, and here we have a 300 point, which is center of the canvas is here. All right, so this is the center point with the coordinates 400 and 300. So when we will provide the center of the center point of the canvas, image will be inserted into the center and will display the whole image. All right, so that's how it's inserted this image into the canvas. Okay, so that's the points you need to really understand how this coordinate system is working. All right, I will hide it, and we'll go back to our configurators. And as I mentioned, your image can have a different origin points. For example, I can call here functions at origin, and I can define here different origin points. By default, origin point is 0.5, 0.5, which is the middle of the image. No change at all. But when I will provide origin point 0, 0, 0, 0, you can also write it just as 0, as 0 will be applied for x-axis and for y-axis. You will see the origin point of the 0, 0 is working correctly. Why is that? Let's go back to our drawing tool. And now let's understand these origin points on the assets. So when we are loading our image, our origin point by default is 0.5, 0.5. So 0.5, 0.5 is this origin point here. All right. And here is the x-axis. I should mark it here. Here is a x-axis, of course, and here is a y-axis. And this top origin point is 0, 0. Okay, so 0 on the x, 0 on the y. So this is the 0, 0. Now you can very easily orient here when you will take a look here. And the middle point is 0. The entire width of this image is marked as a number 1. So when you want to go in the halfway on the x-axis, this means 0.5. Halfway on the y-axis is 0.5. So therefore coordinate 0.5, 0.5. All right, so that's how the origin points are defined. So 0.5 on the x-axis, 0.5 on the y-axis, and this will get me this origin point 0, 0. All right, when I'm going the entire length on the x-axis, this will make me origin point 1, this right top corner, and the 0 on the y-axis. Okay, so this will be point 1, 0. This point here is on the x-axis is a 0.5. 0.5 and 0 on the y-axis, and we can continue like this. On the x-axis here we have a 0, and on the y we have 1. Here we have on the x-axis we have a 0.5, 0.5, and this should be point 0.5 and 1, and here we have a 0.11. So that's how the origin points are defined on the image. Okay, so coordinates here starting 0, 0. The entire width of the image is marked as the 1. The height of the image is also marked as the 1. So when I'm going the entire width of the image on the x-axis, this will make me 0.1. There is no y in this case is a 0, okay, because I don't need to move on the y-axis. And here I have 0.01 because on the x-axis I don't need to move here, but on the y I'm going 1. Okay, I hope it makes sense, guys. So that's how the origin points are defined, and therefore when you will be playing with these values here, for example, origin point you will define here 0.1. This will provide your image differently on the canvas. For example, here 1 and 0 origin point. Okay, now we don't see image because we are providing here origin point 0, 0, but when you will get here center of the canvas 400, 300, you will get into the, now you can see how the origin points are applied to the image. Okay, so 0, 1. All right, 0, 0. 0.5, 0. You can see how differently these images are inserted into the canvas when you are providing different origin points. Okay? So depending on these origin points, the image is inserted differently into the canvas. All right. When the 0, 0 it's inserted by this into the center. When we'll provide the center point of the image, then the center of the image is inserted here. All right. All right. So I will continue. I will provide here correct coordinates. So what I like to do is to provide a 0, 0 point and origin point of the assets we are loading 0. So we'll get a sky image. Now let's load here a player. I will load here the asset called bird.png, which is just a square, yellow square here. We can preload it for sure. So in a preload, let's write here load image. We'll provide here a key for the image, which is a bird. Or of course, you can provide your preferable name, how you want to call your asset. It should be just a unique string. So assets/bird.png, that's a path to this file, assets/bird.png, and then when the bird is loaded, we'll add this image there. Add image, we can add it on the point, let's say in the middle of the canvas. So let's add me this on the coordinates 400, 300, and let's add there bird and set origin. We don't need to do any origin in this case. All right, when this will happen, the bird will be added. The game object of the image will be added into the game. So far, there are no physical forces applied to this game object. We would like to apply to the game object some gravity. So the game object is pulled towards the ground. Okay. So this is going down on the y-axis. So it's going this direction. All right, so if you want to create game objects to which also applies some physical forces, we need to create a game object differently. All right, so how we need to create a game object will be, not this add image, but this will be this physics.add.sprite. All right, you need to provide here x-axis, y-axis. This will stay the same. We will also see that we are applying everything as before. There is a bird here, but now we can apply some physical forces to this game object. All right, so what we can apply here, for example, will be the gravity to the bird. So I can access the bird game object. It's actually the type of this object is a physics arcade.sprite. So there's a sprite. Okay, and we can assign it to the member variable. Let's call this member variable just a bird, and we'll provide here this bird. We'll apply here gravity. So when you want to apply gravity on the sprite game object, you will just call here function set gravity. The axis of the gravity will be y-axis, and it will apply the number, let's say 200. All right, so set gravity y 200. Now when you will go to your game, you will see the 200 gravity was applied to the game object. What does it mean, 200 gravity? The 200 means 200 pixels per second, so 200 pixels per second. All right, so your game object will be moving in time of the 1 second 200 pixels, in the time of the 2 seconds it will be moving 400 pixels, and so on. Okay, so in the time of the 1 second it will be moving 200 pixels. In the case of in a time of the 2 seconds, it will be already moving 400 pixels. In time of the 3 seconds, it will be moving 600 pixels, and so on. All right, so that's how fast the game object will be moving downwards on the y-axis, 200. All right, and we can see the speed also. I will show you one more lifecycle function I didn't show you before. Very important one. It's called update. Let's write here update function. An update function is called on each render of your game, re-render of your game. It's called roughly 60 times per second. So it's called 60 times per second. So your game is running on 60 FPS. So the update function, you are getting two parameters, time and a delta time. And the time is a time in which update was called. It's a time it's a time in a milliseconds, and the delta is the time from the last frame. All right, so when you will console log here time, you will get here time in a milliseconds. All right, so you can see now when I will open here console, I'm getting here the time in a milliseconds from the start of the update function was called. So I'm getting here time. It started to be called on the 800 milliseconds, and it's called on, I think it's called every 16 milliseconds. Okay, so now it was 14 seconds from the update, 15 seconds from the update, 17 seconds from the update, 18, 19, 20 seconds from the update. Okay, so this is the total time from which the update was executed, in which the update is executed. Delta time is different. Delta time will be the time from the last frame. When your game is called 60 times per second, this means the time will be around 60.6 milliseconds or 17 milliseconds. It makes sense because when you will count it, I'll show you. Get here calculator. Okay, so our game is called, let's say the time from the last frame is around 16.6 from the last frame. When your game is called 60 times per second, so times 60, you will see you're getting here roughly 1 second, so 1000 milliseconds. So 16.7, 60.8 milliseconds from the last frame times 60 is that your time in how often your update function is called. Okay, so this will get me sign that it is indeed, it's called 60 frames per second. Okay, so the time from the then console log me here velocity of the my game object and reset me delta time to the 0. All right, so when this will happen, you will see on every second, I will get here, I'm moving 200 pixels per second, I'm moving 600, so you can see every second I'm increasing 200, 300, 600, 800, 1000, 1200, and so on. Some small differences are there, that's okay. All right, so that's how the gravity is applied. It's a time, it's how the speed is applied to the game object. So how fast game object is pulled towards how fast the object is actually speeding up towards basically the ground on the y-axis. Then you have also velocity, as you can see here. Just velocity, just simply the change of the rate of the speed in some direction. In this case, in the y direction, so it's pulling us down. So we are going downwards. We are going on the y-axis down. You can have also gravity on the x-axis. All right. Okay, so like this. Okay, so what do we want to do now? We don't want to just let our player to fall. And now my console log is completely stuck because I am console logging out here too many data. I think my stream is stuck. All right, let me. Okay, I'll just I will comment this out. Not this, but just only inside of the update function. All right, so now all should be good. I can clear it out and I can close the console. What we want to do, we would like to fight against the gravity. So how can we fight against the gravity? I'm sorry for this. Okay, just 1 second. Let's get a break for a second, okay? All right, so break is over. Okay, I hope everything is working now. Today, really, so many unexpected things happening. First my internet, then the neighbors. All right, but we can continue. I even forgot what we have been working on. Okay, so we want to fight against the gravity, right? So we are falling towards the ground on the y-axis. Let's stop our game object for a second. All right, so and let's see here. So we are pulled down. All right, let's say 200 pixels per second. So when we want to fight against the gravity, we need to provide some upward force. We need to provide some upward velocity. Okay, so we need to go on the y-axis, but we need to go negatively on the y-axis. We need to provide here negative values to the y. Okay, so let's say minus 200 to the up direction. Okay, and we would like to apply this force when we'll press the mouse button or some key on our keyboard on the canvas. Okay, so when I will be pressing my mouse, I would like to provide this upwards force on the y direction. Okay, so we will go up. Okay, so how can we do it? All right, I hope the sound is working and everything. A little bit concerned. Okay, I think everything is fine. All right, so let's apply this upward force. Let's go back to our conjugators. And we need to register here one event, point turn down event when we are pressing the mouse key on the keyboard. So let's apply here gravity again. I will remove these comments. You can still access them. It's just making here unnecessary mess. And after the gravity is applied, I'll write here this input on, and we will capture the event of the pointer down. So when you are pointing with the mouse on the canvas, the callback function will be executed. So console log here, let's say hello world. All right, so hello world, it's applied. Let's save this. Let's go back here, and when I will open the console and I will point here, you can see I'm executing hello world. But instead of the hello world, I would like to apply some upward velocity. Okay, so you can do it very simply. You can just access your bird game object and you can apply here velocity. So set velocity on the y-axis, and you can apply the negative velocity of 200, let's say. So now every time you'll be falling and you will point into the game, you will be going a little bit up. Okay, and we can apply even more gravity. So let's say we'll apply we'll apply the gravity of the 600 and we'll apply 300 up. So it will be much faster and responsive. Okay, perfect. Now we need to move our game object more to the left. Okay, you can simply just change coordinate on the x-axis. So let's find here a bird. Here we are providing 400. So this is basically this coordinate 400. We are providing here 400 here. But we would like to provide it somewhere here. So let's say it will be maybe 20. All right, on the x-axis. Okay, so let's get here. Position of the bird will be 20 on the x-axis. Okay, so this will move the position of the bird here. We can even go with a bigger value. Let's say 40. All right, like this. All right, guys. So one thing, when we are falling down, we are going out of the bounds of our game. So I will set here some colliders. You can do it like this. You will access your bird game object, this bird, and you will provide your function set collider world bounds, and you will. I don't even know if I can mark it as a true. Yeah, I will mark it as a true value. So our game object of the bird will be colliding with the edges of our map. So you will see when I will fall down, I'm not falling any longer more down, but I'm colliding with the world bounds. All right, so this is working perfectly. And now what we need to do, we need to create some obstacles in the way of the player. So what I would like to do is to create some pipes in the wave. So let's say we'll create a pipe like this. This will be, okay, let me create the pipes. I'll actually just to show you how I want to add them. So let's say this will be one pipe here. The lower pipe here will add here. Let's say pipe will be here. And here will be this opening, and more pipes will be also rendered here, just in the right side of the canvas, out of the bounds of the canvas. Okay, I would like to render 4 pipes in the way of the player, and these pipes will be moving. They'll be moving towards the player. Okay. All right, so we need to create these 4 pipes. Actually 8 pipes, because we need to create 4 upper pipes and 4 lower pipes. So let's create a pipe. We'll start very simply. We'll create only a pipe. Let's go back to our coding editors. And the pipes, you have also image of the pipe. You have in assets folder. Here in the assets and pipe.png, here is the pipe. All right, I hope this is visible for you. I will just make this smaller. All right, so we need to preload this. We need to preload this pipe. Let's scroll up here into the preload function, and in the preload function, you will preload the pipe. So you will call this key of the pipe, and you will load your assets pipe.png. All right, so as pipe is preloaded, we will be creating it in a create function, or we can create a separate function for it. So under bird, I will create here function. I will call here create pipes. I will create this function down here, create pipes. All right, and I'll create here this pipe. So this pipe. All right, we will create it similarly as we are creating our bird game object. So let's call here this physics dot add dot sprite, and we'll add here on the coordinate, let's say in the middle of the screen, so 400, 300, we'll add here pipe. Now when you will save this, you should see here the pipe. It should be added in the middle of the screen. Okay, and we'll add here also the lower pipe. Give me a second, one thing here. Well, it will be better, I guess. Okay, so we'll add here this pipe, maybe a little bit higher, the pipe, and the origin point of the pipe will be left bottom corner. So I would like to add the pipe like this. All right. Okay, I will add pipe. Okay. So pipe will be added here, and the origin point of the coordinate will be this point here. All right. So an origin point of this is on the x-axis, it's a 0, on the y is 1. So this is the origin point of a 1 or 0, 1. And the coordinate will be, I don't know, on the x-axis, let's say this can be 400. And then the y-axis, it will be 300, right? 300 on the Y, and will be added with the origin point of here. So image will be added on this origin point. By this origin point, it will be inserted into the canvas. Okay, so let's add this pipe like this. Let's go back and let's choose here this origin point. So the pipe, and here we'll be setting origin, set origin of 0 and the 1. All right, that's better. Or maybe we can even provide here 300, 300, or 400, 200 on the y-axis, so it will be a little bit up. And now let's create a down pipe, the lower pipe. The lower pipe will have an x coordinate of the upper pipe. So let's say this down pipe will be here. All right, and it will have the same x coordinate, of course, because the x coordinate of the upper pipe is not changing. This will be same x coordinate. All right, it will be same x coordinate as the upper pipe. But the y coordinate will be different here, okay? Because y coordinate here is here, let's say, I don't know, we added here 200. Okay, so this is a 200 here distance. But here I would like to add, let's say, plus 100, so this will be 300, okay? So here will be plus 300, so here will be another 100 here. So this will be in total 300. Okay, so x coordinate will not change, it will be same as the upper pipe, and the y coordinate will be 100 pixels more than the upper pipe, so it will create this nice opening here. All right, so let's get back. We'll assign this pipe. We are already assigning this pipe into the pipe variable. So we'll create a second pipe. I'll call this actually upper pipe. Upper pipe, and this down pipe I will call the lower pipe. Lower. I don't see on the keyboard to the to the microphone. All right, and we'll create here physics.add.sprite, and the coordinates will be the same as their upper pipe on the x-axis. So I'll get this upper pipe.x, and the y-axis will be y plus 100 as I told you. And the key here will be pipe. And the origin point will be different here. So right here I set origin. Origin point will be the upper part of the pipe, so it will be origin point 0, 0. Okay, so origin point here. Origin point of this upper pipe of the lower pipe will be this left top corner. Here will be origin point of this pipe. So the pipe will be added into the canvas by this origin point here, 0, 0. Okay. So the coordinate system here, oops, will be added here. Okay. All right, so set origin 0, 0. We can save this now. Let's go back to our browsers. And you can see this opening 100 pixels, and we are adding it exactly 100 pixels down from the upper pipe. All right, so I can even write it like this if it's visible more for you. I don't know how you're seeing it. I think you should see it good here. Okay, like this. Add sprite. Set origin point here. All right, guys. So we are creating our pipes, but I would like to create the 4 pipes in the way of the player. So the pipes will be also created when they are not seen. So we'll create one pipe here, the one pipe will be here, as I showed you before. So we'll create 4 pipes in a total, and the pipes will be moving towards the player. So now let's focus on this. Let's create 4 pipes, and let's move them towards the player. Okay, so I'll remove this. All right. Okay, and let's go back to our coding editors. I will create here a function to place pipe, okay? So I will call here function place pipes, and the place pipe function will be responsible for placing a pipe. We can call it just a place pipe. And the place pipe will be placing the upper pipe and the lower pipe. Upper pipe and the lower pipe, all right? So we need to add this, we need to execute this functionality, what we are executing now, we need to execute it 4 times. All right, so let's do it like this. Let's write here iteration simple for loop, okay? So for loop, and we would like to loop here 4 times. So I will create here some variable. Let's say up here for now. Okay, so const, and I call it pipes to render, and let's render here five pipes. All right, so pipes to render. Let's scroll down here and let's iterate here 4 times. 4 times. I wrote here 5. Let's iterate only 4 times. All right, so now we will be writing here let y, it's 0, 0, y is the less than the pipes to render. So this will be exactly iterating 4 times, and we'll increment y plus plus, and we'll call here this place pipe. All right, and now we would like to place our pipe here. Before that, I will create my pipes. So I will move this part, and I will paste it here, and I will create here this only in local variables. I'll write here const upper pipe and the const lower pipe, and I really don't care about the coordinates here where these pipes will be placed. I will place them simply on the coordinates of the 0, 0. All right, and here I will place them on the coordinates as well, 0, 0. I don't really care where I've been placing them. Okay. Now I will get these 2 pipes and I will place them into my placePipe function, and the responsibility of the placePipe function will be to receive the both pipes and set them to the correct coordinates. Okay, so I'm getting here upper pipe and the lower pipe, and my responsibility now is to update their x and the y coordinates. So I will get here upper pipe.x. Let's assign here some value. Let's mark it as 0. Let's write here upper pipe.y. Let's assign here some value, and the same for the lower pipes. All right, so I will get here lower pipes, lower pipe.x, and lower pipe.y. And what coordinate do you would like to provide here? As we had it before, x should be 400, y should be 200. Now the lower pipe x should be the same as the upper pipe, so we can copy this. This is the same as the upper pipe.x. And the lower pipe should be the upper pipe y plus some value we said before will be plus 200. All right, let's save this. All right, perfect. So we are creating 4 pipes. It's not maybe visible, but we are placing them in the same exact spot. So they are overriding each other. 4 pipes are on the top of each other. What we want to make here is to place them, let's say, in some distance. So let's say after we will place the first pipe, the second pipe will be placed 300 pixels to the right. We'll place this pipe. When we'll be rendering the third pipe, we'll place the third pipe 300 pixels from the last pipe. So 300 here will be placed here. Okay, and the fourth pipe will be the same, so we'll place here 300 pixels from here. Okay, so we'll be doing it like this. All right, so I will remove this. So now we know that we need to place them 300 pixels from each other. Okay, let me close this. Actually, we can keep these variables, upper pipe x and the lower pipe y. We can separate them into separate variables. Let's say up here, before we will iterate here, I'll write here this pipe horizontal position. Okay, let's say horizontal position will be 400 in this case. That's x coordinate. This, let's say pipe vertical position, and let's say this will be 200. So I can get these values dynamically from this variable. So this pipe's horizontal position will get to the upper pipe x, and the pipe vertical position will go into lower pipe y, upper pipe y. Okay, so we are getting the correct coordinates. Okay, perfect. Now we need to space them. So we need to get here upper pipe x plus some distance each iteration. But the first iteration, when we are creating the first pipe, this distance should be 0. Okay, so let's say our pipe horizontal position will be, let's say, let's create a variable. We'll call it this pipe horizontal distance, pipe horizontal distance, and let's say distance between the pipes will be 300 pixels, as we showed on the image. So I will say here, instead of this horizontal position, I will get here this horizontal distance. Or actually I will do it completely differently. I will say the horizontal distance 0. Okay, so I will say here this horizontal position plus this horizontal distance. By the default, initially it will be 0. And after I will add a pipe, I will access here my this pipe horizontal distance, and I will increment it. I will add here plus 300. So plus equals and 300. All right, so on the first iteration, we should get here a pipe horizontal position, which is a 400 plus 0. We'll place the pipe, we'll add here 300 to per horizontal distance. On the second iteration, we'll get here horizontal position plus 300 and so on. I will debug it for you so you will see it how it works. All right, let's save this and let's go back to our browsers. And now you can see we have here multiple pipes. Maybe you cannot see all of them because some of them are hiding on the right side where our canvas don't have such a big canvas. So let's go to index.js and you can simply increase the size of the canvas to 2800 pixels. All right, and you'll see the canvas will be much larger now, and you can indeed see this 4 pipes, and each pipe is distance 300 pixels from each other. When you will write a debugger to your code, you will see how it's added. Let's write here a debugger. All right. Let's go back to our browsers. Let's open here development tools. So right click and inspect, and let's see development tools. Let's refresh your browser, and you should see here that we are jumping into the code of a place pipe. The place pipe we are placing here, we are adding here upper pipe X position, which is currently 0, but we are adding here horizontal position, which is 400, plus pipe horizontal distance, which is a 0. Now we are going into the Y direction. We are adding here pipe vertical position, which is 200. And the lower pipe has the same coordinate of the X as the upper pipe. And the lower pipe has the same Y coordinates, the same as the upper pipe Y plus 200 pixels. Then after the pipe is added, we'll increment pipe horizontal distance by 300. When this happens, we'll get into the second iteration. We'll get here pipe horizontal position, which is originally 400, but we'll add here another 300 to it. So pipe horizontal distance in this case is 300. We'll add them together. We'll count the X position, Y position the same as before, and it will again increment horizontal distance. Now it's 600, and we'll go to add the next pipe. All right, so we'll add the next pipes here. Again, we will add here position, which is originally 400 plus now this 600 here. All right, and that's how it works basically. So after each pipe is added, we are adding here some number to the horizontal position so we can space it from each other. All right, so yeah. That should be it for placing pipes. So now we know how to place them, but we would like to apply some velocity to our pipes. Okay, let me check this out. All right. Checking if the stream is still working on. All right. Okay, so if everything seems to work, it looks like you don't have many questions here. It's better for me. I don't need to answer here anything. All right, so yeah, next we should apply the velocity. So let's see what we are working on. We're adding here sprite, applying gravity, adding control to the player. Yes, add pipes and move them towards the player. Okay, so now we need to apply this. We need to apply the velocity to the pipes. Okay, so we need to move them the left side. So we need to apply velocity on the x-axis. So this is the x-axis. And it will be negative velocity, okay? So this will be negative velocity, so it's going to the left side. Positive would be right side. Okay. All right, so let's apply the velocity to this game objects, but I would like to do it differently. I would like to add all of these pipes into the group. When you will add game objects into the group, you can apply the force to the group, and all of this will be added, all of the velocity will be added to every member of the group. Okay, let me show it to you. I'll create here pipes, member variable, so these pipes. And we'll create here a group, so let's call here this physics.add.group. All right, and we'll be adding these pipes. So you will create the pipe differently. You will be not creating the pipes with the function physics.add, but you will access here your group, these pipes, and you will use your function.create. I can remove this part even. Okay, I can write as a one-liner now. It's pretty clear what's happening here. Okay, so upper pipe, lower pipe, and the same will apply for the lower pipe. So we'll add here these pipes.create. All right, and we'll remove this part here of the sprite. So we are adding upper pipe, lower pipe. Now we are adding them through the group. All right, guys. So now when you are adding the pipes like this, when you writing here these pipes.create, the pipe will be also added into the group here. Okay. So we'll add to the group of the pipes in total 8 pipes. Okay, let's save this. Now everything should work as before. So when you will go to browsers, you can see here, you are displaying here these 8 pipes here. Everything is working, but now you have access to all of the members of the pipes group. Okay, so when I will write here these pipes, or actually after it, I'll write here these pipes, get children, I can get all of the children of the pipe group. All right, here, debugger. All right, and now I should get into the A variable, I should get all of the children of the pipes group. So in the total 8 pipes, I will open development tools, I will refresh. Okay, and we'll get here 8 pipes. You can see all of these arcade sprites were added to the group. All right, so now we have this access to all of the members. And you can simply now apply physical forces into the entire group. So I can access here these pipes. All right, and I can apply here set velocity on the x-axis of -200, and this velocity will be applied to every member of the group. So now we'll get it running. You can see all these pipes are moving toward my direction. So they are moving on the x-axis to the left side with a velocity of 200 pixels per second. What we need to improve now is whenever the pipe will go on the left side, it's not any longer visible on the canvas, so it's going out of the bounds of the canvas. So the pipe is getting into this position, like this. When it's getting into this position, we need to detect this and we want to replace the pipe. So every pipe that will get out of the bounds of the canvas will get recycled in the starting point here on the canvas on the right side. Okay, so it will go like this in the cycle. So the pipes will be moving from here. All right, pipes will be moving. Okay, and as soon as they will reach the end, they will be recycled. So they will be position of the pipe will be changed from the start. It will go into the ending position. Pipe will be respawned here, and it will be moving towards the player again. Again, when we'll get into the start point, it will get again recycled and it will be moving in the cycle. So we don't need to create any new instances of a game objects. We can simply recycle them. All right. So that's basically what we need to implement. So we need to detect whenever the pipe will go out of the bound. So we need to detect this position here on the pipe. So what we need to do, we need to check for this position on the right side of the pipe. We need to get this right position. Okay, this is basically X position here on its X-axis. And if this position is smaller than the 0, then we know that we are out of the bounds with the pipe. Okay, so one more time, if I wish I would mark it smaller or nicer. So when the pipe will get into this position, when the position of the right side of the pipe, so this position here, will be out of the bound. So if this position is smaller than 0, this means pipe is out of the canvas. All right. Okay, so let's implement the solution for this. I will go back to my coding editor. I will close this. All right, so let's create your function. We'll call it recycle pipes. Recycle pipes will be called on every update, and on every update we'll be checking if the pipe reached the position which I mentioned before. So I'll create your function recycle pipes. And here we'll get every member of our pipes group. So I will get here these pipes dot get children, and I will iterate here through all of the children, through all of my pipes. So I will write here for each. I will get here pipe. I will write here arrow function. So in each iteration, I will get a single pipe. And I would like to check if this pipe is out of the bounds. So I'll write here if the pipe, if you would like to get the right coordinate, the coordinate I showed you before, this right side of the pipe, you need to use your function get bounds, plural get bounds, and you need to get the right position. If this position is smaller than 0, this means your pipe is out of the bounds. And you can console log here, let's say console log I should get recycled. All right, so and now let's call the recycle pipes on every update. So you'll call it 60 times per second. So on the update, we'll call your function these recycle pipes. All right, and let's go back to our browsers. Okay, so let's see. I'll refresh, and as soon as the pipe will move the left side, you can see I should get recycled. So as soon as the pipe will be moving out of the bounds of our canvas, we are getting here console log I should get recycled. So what we don't want to do in such a case, when we are getting there, we would like to replace the pipe. So we need to get the upper pipe, we need to get the lower pipe, and we need to recycle them. So I'll create here temporary variable. I will call it temporary pipes. Call it const temporary or temp pipes, and there'll be array. In this array, I will push the pipe which is out of the bounds. So if the pipe reach the ending of this pipe reach the out of the bounds position, then push me this pipe into the temporary pipes. So let's get me here temporary pipes and push me there this pipe. And if the temporary pipe's length will be exactly 2, so if the temporary pipe's length will be exactly 2, this means I got my upper pipe and the lower pipe, and I can reposition them. So I can call here this place pipe, and I can position it, I can provide here upper pipe and the lower pipe. So I can call here temporary pipes on the index of 0. This will get me upper pipe, and the temporary pipe on the position of the 1. All right, let's see if this will work. Let's save this and I will debug it after. Okay, so I will get a pipe here, and you can see it's getting recycled in the end of the map. The position is not very correct. We need to still fix it. We'll be working on this very shortly. And yeah, but it's getting recycled. You can see every pipe is added further and further from each other, which is not good. Okay, we'll need to fix it, but the point is it's working. And we can write here debugger. I'll write here debugger here. Okay, so let's console, let's refresh, and you will see as soon as the pipe will reach the ending point, we'll get into the debugger, and we are getting here pipe. So this pipe is out of the bounds. We'll push this pipe into the temporary pipes. All right, and then we are going next to the next iteration. Okay, we don't have a temporary pipe's length is not 2. We don't have, still we are missing the lower pipe, so we'll wait until the next iteration. In the next iteration, we'll get the lower pipe. We'll push it to the temporary pipes. Now we have in temporary pipes 2 pipes. And if the temporary pipe's length is equal to 2, so we have an upper pipe and a lower pipe, we'll place here pipes. So we'll place here upper pipe, this temporary pipe on the index of 0, and temporary pipe on index of 1. So the upper pipe and the lower pipe will be added, will be placed correctly. Which actually is not correctly positioned yet, because we need to adjust our place pipes function. All right, so let's get back here, and I will remove the debugger from here. Okay, and we need to do some restructurization of the way how we are getting the horizontal position here in our place pipes. So this position here of our upper pipe, of the X position of the pipe. What I would like to rather here get here, when we are placing pipe, I would like to get here current rightmost pipe. So let me show you. All right. Actually, we should stop this for a second. I will stop it for a second so I can draw it nicely. I'll comment out create pipes. All right, and yeah, let's. Okay, now I introduce here issue because for some reason I comment this out and create pipes. We are calling recycle pipes. So I will comment recycle pipes as well. Okay, I just want to show you canvas. All right, so let's draw it not here. Let's draw it here. So whenever I'm placing the first pipe, my default position will be, let's say, 400 pixels on the x-axis. 400 pixels on the x-axis, so I'll position here first pipe. The second pipe will be positioned relatively to the first pipe. So we'll get a position of rightmost pipe, this one here, and it will increment here plus 200 pixels or 300 pixels. So the position of the next pipe will be plus 200 from the last pipe. All right, and the same with the third pipe. Third pipe will be getting the position of the rightmost pipe, which is not this pipe, but the rightmost pipe is this one. So we'll get this position, and we'll add here plus 200, and we'll place the another pipe next to it. All right, so that's the idea behind this. We need to create a function for this, of course. So I will comment this out. I will remove this brush tool. I will hide it. Actually, I don't want to remove my brush tool. All right, and let's recycle pipes. So I will comment this. I will uncomment recycle pipes. I will uncomment create pipes. So everything is working as before. You can see it's working as before. And we'll create this function to get the rightmost pipe. So let's create your function under recycle pipes. I will create a function. I will call it get rightmost pipe. I will get here current position of the rightmost pipe, so I'll call it let rightmost, and the default position of the rightmost pipe will be 0. Then I will iterate over all of the pipes. So again, these pipes for my pipes group, I will get here children of this pipes group. I will iterate here with a for each, and I will iterate over the pipe. Okay, so each iteration I will get one pipe, and I can check here if the pipe is the rightmost pipe. Okay, so I will get here rightmost pipe equal, and I will get here maximum from the pipe on the X position and the rightmost pipe. I will debug it for you guys in a second so you'll understand it, okay? And simply I will return from here rightmost pipe. Okay, so now you can imagine, guys, rightmost pipe by default is a 0. So first rightmost pipe will have a position of the 0. Okay, and when we'll go in the second iteration, we already have some position on the X. Okay, actually, guys, let me test it out. We will test it out, and then we will debug it, and we'll explain this how does it work. Okay. So I will get the rightmost pipe. I will get here. I will get it here to the place pipe. I'll create here a variable called rightmost pipe X. I'll call here this get rightmost pipe, and then I'll get here get rightmost pipe X plus this pipe horizontal distance, and I will remove this last pipe horizontal distance. Okay, and now let's take a look on this pipe horizontal distance. It's currently 0, that's not good. Let's add here, let's say 300 pixels. So each pipe will be 300 pixels from each other. Okay. Let's take a look on this now. So when pipe getting recycled, it's getting correctly positioned next to each pipe. Alright, this is working. And let's explain this. Okay. So let's see this iteration here when we are getting rightmost pipe. So you need to understand when we are placing the first pipe. Alright, so we are placing the first pipe. Okay, our first pipe, we are comparing here, we are getting here first children, and when we are adding first pipe, we don't have any children here. So our rightmost position is 0. Okay, so we are trying to get a maximum from the 0 and the 0, which is a 0, and we are returning 0 here. So we are positioning we are getting here position of the 0 up here in the rightmost pipe, and we are adding here 300 pixels. Now upper pipe has a 300 pixels position. So when we are adding second pipe, we already can get a position of a 300 pixels and compare it again with the 0, which will get me a position of a 300 pixels. I understand it can be still a little bit hard to grasp this concept, so I'll write here debugger. and you will see how we are positioning it. All right, so already the debugger here will go back here, and you will see when I will refresh the refresh browser. Okay, so we are getting here a pipe. Our current pipe X position, because its first pipe is position 0. We are getting here, we are comparing here, we are getting maximum from the 0 and rightmost, which is 0, which get me rightmost of a 0. All right? Then I will get here, getting here lower pipe again is a 0, which will get me again rightmost pipe 0, and I will return 0 position 0. I will get a 0 here, and I will get here 0 plus pipe horizontal distance, which is a 300, so it will style it 300 pixels from on the canvas. All right, then we will iterate here again, and we are adding here a second pipe, so we'll get again. We will get here first, we are iterating over the pipes, we are getting here first pipe position is 300, rightmost is reset to the 0, so the rightmost is so far 300. We'll get here lower pipe, the 300 rightmost, and then the second pipe, the rightmost is still 300, and the pipe position is here 0. Okay, so we'll compare it, and the rightmost will be 300 in this case, so we'll return the rightmost pipe position is 300. So this will get me 300 here, and I will add to the 300 horizontal distance, which is another 300. And this will get me upper pipe position. Okay, so basically I'm getting always the last active pipe position, and I am adding to it 300 pixels, as you can see here. Okay, so I'm getting last position pipe and adding 300 to it. Okay, so the pipe is getting spawned, and 300 pixels from the last pipe, from this pipe here. Okay, you can see it's always 300 spawned. All right, so I can close it. And since we are positioning already pipes, I will do here one improvement before we'll finish this stream, I guess. It will be enough for first stream after these technical difficulties and all of the stuff. And we'll finish the game in the next lecture. What I would like to do here, I would like to randomize some things. For example, I would like to randomize how far are my pipes from each other. This we can do very simply. Let's go up here and let's get here pipe horizontal distance. I will move it from here and I will place it to the place pipe function. And I will randomize it like this. I will get here phasor.math and a between, and I will say the pipe horizontal distance will be between, let's say, 300 and 400 pixels. So now every time the new pipe will be spawned, it will be spawned between the 300 and 400 pixels. You can already see the distances between the pipes are a little bit different. All right, more obvious it would be if I would add here between the 100 and 400. So this will choose just the number in between of this distance. It can be 100, it can be 400, it can be 300, 250, but it has to be from this distance. Now you can see the pipes are spawned very unpredictably. Okay, so that's the horizontal distance. I will revert it to 300, 400, that was okay. And also you'll randomize our pipe vertical position. Okay, so let's get here pipe horizontal position and vertical position from here. I will copy it. And I will move it down here. All right, let's say our pipe horizontal position, vertical position. Okay, horizontal position can stay the same. My mistake, I can leave it up there. Okay, I'll leave it here, and pipe, I'll get here a variable called pipe vertical distance. This pipe vertical distance, and let's say this can be randomized. Okay, so this will be phasor.math.between, and this can be between, let's say, 200 and 300. Okay, 200 and 300. And we'll use this pipe vertical distance where we are adding this number, this distance to the y direction. So we'll get here this pipe vertical distance. So this pipe vertical distance. So now we should be randomized also on the vertical position. You can see it's randomized also on the vertical position, but it's not so random because the upper position is still the same. So we need to change also upper position, the y position of the pipe. All right, so how can we do it? Okay, let me see it. So we need to change this. Okay, so I'll add here phaser dot math and between also. And now let's change the range of our canvas. When can be starting position of our pipe? Okay, so starting position of our pipe, we can place the pipe anywhere on the canvas, right? So let's say it can be from on this distance here. Here. Okay, so the pipe position can be from 0 to 600. Of course, that's not true, because if we will place, if this pipe will be placed here, so starting point of the pipe will be here, so upper pipe will get here, and the lower pipe will have an opening of 200 pixels. This will go out of the canvas. So this will lower pipe will be positioned somewhere here. Okay, so we need to somehow figure it out position. So it will be, for example, between here or between here, or let's say here. So let's say we will place the pipe between the position of 20 to 580. Okay, remember our canvas has a height of the 600. Okay, so 600 canvas, I'll mark it like this, minus 20, minus the pipe vertical distance. Okay, so minus this pipe vertical distance. We need to count with the pipe vertical distance. Okay, because if the position would be the larger than the pipe vertical distance, then the pipe could be created under the canvas. Okay, so we need to also count here pipe vertical distance, and simply then I can add here on the Y position only this pipe vertical position. Okay, so now I think it should be randomized also, or actually, all right, I messed up here something. Okay, that doesn't work at all. Now the position is completely messed up. Okay, let me see what I add here. Position of the pipe vertical. Okay. The lower pipe Y should be the upper pipe Y plus pipe vertical distance. My mistake. Plus pipe vertical distance. All right. Now it's correct. Okay, and you can play with these values as you want. Let's say I will decide the pipe vertical distance will be only from 100 to 150. And this will adjust my game accordingly. So you can see these openings are much smaller. So now I can randomize them. All right, and I guess that should be it. If you have any questions, you can just place them under this video after the stream is over. There will be discussions. You can just place the comments if you don't understand something here. But the really most important part here is to understand how the coordinate system works here and how you are inserting the pipes on the correct positions. We are setting here coordinates between these ranges. So we're simply getting here distance and the positions, and we are setting our pipes according to these positions. Lower pipe is always set relatively to the upper pipe. So we are getting upper pipe position and we'll adjust just the Y position with the pipe vertical distance. So if the pipe is added here, the lower pipe is added 200 pixels down on the Y-axis. All right, and as soon as we will get the pipe on the left side, it will get a bounce of the pipe, and if the pipe right side is lower than 0, then the pipe will get recycled on the last spot, the 300 pixels from the last active pipe. Yeah, and yeah, that should be it. So if you have any questions, guys, really ask them. And I'm covering all of this in a much compact way in the course, when you can watch it lesson by lesson, and also you can create a platform